So I wanted to make this little video to talk about why we factor. Why do we need to have factoring? And we're going to start with an example where we don't need factoring. And we don't need to factor anything here because, well, we have two terms with x's. They're the same. We're able to combine them by combining like terms. So 2x subtract 3x is negative 1x equal to negative 1. And I can show the steps out, or I just know that x is equal to 1. That was pretty easy to solve. I didn't need to factor because the terms were the same. I could combine them. But if we look at this second example, all of a sudden I have, again, two terms, each with an x, but this is an x squared. It cannot be combined with this, negative 3x. So in order to deal with this, I'm going to need to factor. And when I factor, I want to have the other side of the equal sign be equal to 0. So I'm going to actually add 1 to the other side. I'm sorry, I actually want this to be plus 3. So we're going to have 2x squared plus 3x plus 1 is equal to 0. And I want to have it equal to 0 so that in the end, I can set each little mini piece I get equal to 0. So I'm going to factor this into two binomials. It's going to be 2x and x, because that's how I'm going to get 2x squared. And since it's plus 1 here, the only way to get a positive 1 is 1 times 1. And I'm going to have now two mini equations. 2x plus 1 is equal to 0, or x plus 1 is equal to 0. So it was really important that it was a 0 over here. And now I can just set these little mini equations. Minus 1, 2x is equal to negative 1, divide by 2, x is equal to negative 1/2, or minus 1, x is equal to negative 1. So factoring allowed me to get to two really little mini equations that were then easy to solve. So that's why we factor, so we can solve easier.